Hi, my name is Nino Brown. I'm with the University of Georgia. I'm an assistant research scientist within the Department of Crop and Soil Science, and I'm a peanut breeder. I work closely with Dr. Bill Branch, who's been the peanut breeder here for over 40 years now. Some of the things that we focus on is increasing yield, of course, increasing dollar value, improving disease resistance, as well as shelling quality, flavor, drought resistance, and just a lot of various agronomic traits that are important to growers. Plant breeding is an expensive, slow, resource-intensive endeavor, and peanuts are especially so. You know, it requires a lot of people and a lot of specialized equipment to breed peanuts. You know, it starts with a cross, and we plant those hybrids in the field. We harvest individual plants from those hybrids, and then we plant nurseries every year from those populations, and individually select plants and individually harvest those plants. And it's very time consuming, and it's a slow process. First of all, we're really lucky in the peanut research group here at UGA to have the support of the Georgia Peanut Commission and the leadership that they show in advancing research at the University of Georgia for peanuts. A few years ago, I gave a preliminary presentation sharing some drone data, sharing how we were using drones in our peanut breeding plots. And Don Kaler approached me to see if a ground-based phenotyping robot would be of any use for looking at traits that are really detailed. And of course I said absolutely, that would be really helpful. So Don put together a group of engineers and people with experience in robotics in agriculture, and we had a meeting and we discussed the potential for developing a robot. We looked at some of the robots that are currently available on the market and decided most of them really wouldn't work for peanuts very well. And so we had to start from the ground up. We've been working with our collaborator in Athens, Charlie Lee and Ray Hsu in the College of Engineering to develop a ground-based high-throughput phenotyping vehicle platform. They call it Watson. It is designed to drive autonomously through the field using GPS to take measurements. Right now we're starting with, it just takes pictures of the plants, and then we use software to analyze those images. We're hoping to use other types of sensors, multispectral sensors and things of that nature to help us take really detailed measurements of, say, disease symptoms, plant measurements, leaf shape and leaf dimensions, plant architecture, things like that. So that instead of only being able to cover, say, a couple hundred plots in a day, maybe we'll be able to cover several thousand plots in a day to really increase the rate of genetic gain. The initial project was to develop Watson for the purpose of breeding and selection in breeding nurseries. However, there's a lot of application and a lot of potential in the technology for the machine to take measurements in really almost any type of research plots that are done here at UGA, for peanuts anyway. We specially designed it so that it can travel through rough terrain sometimes, muddy terrain. The dimensions of the robot match those what a typical grower would encounter and what typical research plots would encounter. So, we could use it in weed science, plant pathology potentially. A lot of different fields could potentially use the robot for high throughput measurements of plant data. And then growers too potentially someday could use this for autonomous weed control, autonomous scouting of their fields for disease symptoms. Really the potential of the technology is limited by our imagination.